Welcome to this introductory series of training videos for SolidCAM. This video's topic is edge deburring operation. The edge deburring operation is a single operation that will allow you to add a edge deburr, edge break, a chamfer to all the edges of a solid in one toolpath. And as a recognition toolpath, it actually is solid-based. So let's take a look at how all that works. First, to get to that operation, you can go to SolidCAM Operations, Recognition, and edge deburring operation or recognition. If we go to SolidCAM AFRM, we can see edge deburring recognition as well. So to get to the edge deburring recognition operation, you can do up there, or you can do it the old way. After all my toolpaths here where I roughed out the entire part, I can just right-click on my last toolpath, go to add milling operation, edge deburring recognition. Now this toolpath, being a recognition toolpath, it will allow you to select a solid and find a lot of the geometry for you. So that's where we're going to start. In the geometry section, you click New Geometry. There's a couple of filters here, but we'll go right down to selection mode. You can see that you can either select the solid body or individual faces. If I select the solid body, what it does is it finds all the horizontal faces, determines all the edges of those horizontal faces, edges I might want to deburr, and then it selects them in this window here. But you can take note of a few things. One, it did not choose the edges of those holes, and that's because I had that minimum diameter filter turned on. So usually for holes, if they're of a certain size, you might not want to use your chamfer mill or your taper mill to deburr them. You might want to just do a spot on them with a spot drill, or you have other ways of doing that using a drilling operation. So that's why that one is not included there, because I had that minimum diameter. Another thing to note is that I just chose the edges of that surface, and that includes the top edge of this existing chamfer. I probably don't need to deburr that because that's already leading into a chamfer. If we zoom in on this guy over here, that whole interface there is adding some edges there to that solid, and I might not want to do those as well. So there's actually a couple ways in this one toolpath that addresses all those issues. So let's take a look at them in terms of just the geometry selection. So I'll just go back into the geometry. We'll leave that whole filter turned on. We'll take a look at our filters here. So if I ignore the edges that lead to a fillet, I don't really need to deburr edges that lead to a fillet because those are already rounded edges or broken edges. So I can just ignore those edges. And on our part, we have a chamfer. I can say ignore any floor to wall angles less than 90 degrees. So in this case, that doesn't lead to a 90-degree corner. That is actually a chamfered corner. It will now ignore those. In terms of selection mode, if I click on face, it just individually chooses those edges of the faces that I choose there. So that's one way to do it. If I do solid body, I can click on the solid, and then what it does is it recognizes all the edges of the solid that I selected. And you notice that once I turned on that ignore floor to wall, it then did not include those guys there. If we zoom in back on our little corner here, it ignored that floor to wall angle. In this case, it's just kind of a fillet there, so it ignored that guy because of the angle, but it still gave me that little edge over there. So in terms of the geometry, that's the way that you can actually ignore certain edges that you don't want to deburr. But if we zoom in on this edge over here, I'm still looking to deburr that edge, but if I take the tool right to that point, I'm going to gouge that wall. So there's nothing in here to control that. We'll actually control that in the main window where we do things like 3D model protection. So if I already got this solid defined as my target, I'll just make sure that I don't gouge my target wherever I am inside the toolpath. So that's what that guy does. If I want to make sure I protect my part even more, rather than just taking the tool, the arbor, the holder right to a 0 distance away from the target, I can just put a value in there and it keeps the tool away from the target by that amount. Let's go to Tool, and we'll just click on Select to take us to our tool kit. And I'm just going to grab my chamfer mill. But in order to create tools here, you can see that on the left side there, these are the tools that I would be allowed to use in this operation. If I wanted to customize these, I would just make my own shape tools from solid models. To see how to do that, I refer you to the toolkit training videos in a playlist on this YouTube channel, or the creating milling tools operation video in this introductory series. I'll click on the green check mark to select my tool. Under levels, this being a recognition toolpath, all I'm going to do in the level section is tell it how much of the target I'd like to recognize. So I've already chosen all the geometry I want, all the levels, all the faces, but I'm going to tell it how much of those I actually want to do with my upper level and lower level. So it defaulted to the top of the part, but I can always change that upper level to whatever I want if I don't want to actually deburr the top face of my part. Likewise, if I don't want it to go all the way through the entire target and deburr all the edges, I really just want it to go down a certain depth, I can turn on lower level and tell it how far into the part I'd like it to travel. Now, we call this edge deburring, but you are actually using a chamfer mill on a sharp edge, you will generate a type of chamfer. So when it says chamfer depth, it's really just asking you how much of a chamfer you'd like to create. So in this case, I could just put in whatever I'd like for an edge deburr. I could put in maybe 2 thou, 5 thou. I'm going to put in 10 thou just for visual purposes. When we do the simulation, we can see how much that is actually removed from the material. Under technology, again, we are doing a type of chamfering. We're calling it edge deburring, but with the shape of our tool, we will be generating a chamfer. So under chamfering parameters, we can define what spot on the tool we'd like to use for the actual edge deburring. So I have it defaulted to 50 thou. So according to the shape of my tool, 50 thou would sit a certain distance away from the tip. So every one of those chains is actually going to dip the tip of the tool that distance to achieve that cutting diameter. So all your cutter comps, all that stuff is going to be coming off of this diameter as soon as you choose the chamfering option. Depth cutting type, if there was any step down with this tool, you can see here that it would go completely in one way, so it would reposition every time it does a depth of cut, or I can get it to zigzag. Direction of cut, this is a type of a profile operation. It will follow those chains exactly. So I can tell it to either go in a climb or conventional direction. And that is based off your tool selection if you want to go climb or conventional. Now, as we go into corners, we can actually change the feed rate. So what we can do is we can check this box here. And if the corner has a certain amount of material, I can tell it what that previous tool size was used to mill that out. I can tell it if there was originally a wall offset. So between those two, it knows how much material is probably in that corner, where it should start, where it should stop. Overlap / extension. If this was a closed chain, I can tell it how much to overlap to eliminate witness lines, or in this case, extension. From that amount of material we told it that is there, it knows how much to feather out from those edges to kind of do a smoother lead in into that corner. And then as you go into that corner, you can tell it what the feed should be in those corners. But in this case, I'll turn this off. Another level of gouge checking is the offset. So the safety offset is basically a dimension you plug in to tell it how far to keep the tool away from any edges or walls of your part. So in addition to the gouge check we saw in the geometry section, we have this guy here to tell the software to keep the full diameter of the tool a certain distance away from all the walls. So referencing back to my corner there, I'm actually going to look at the shape of the tool and keep it the full diameter of the tool 10 thou away from that wall. And if you have so much of an edge to break that you need to add some step downs in terms of roughing, undercutting, we can add step down, number of copies on the last cut, and then again, extension / overlap if we want to kind of feather our way into there. And then lastly is the minimum edge. So going back to the little edge over here, this I'm not going to worry about because as soon as the tool goes too low, it's going to hit that. It won't even generate this edge. But if I didn't want to even bother with this edge, I can actually put in the length of that edge in here, and it would ignore that minimum edge. And the reason we have a minimum edge length is because there are such times where maybe a really small edge is generated because I've given it a safety offset, I've given it the target protection, and it still thinks there's just a little bit of a room there that can do a little bit of a deburr. If it just goes to kiss an edge, it really is not doing me any good. I might be wasting cycle time just repositioning the tool just to kind of kiss that edge. So I can just put a minimum edge length to ignore that really small edge that it's trying to deburr. And then lastly, in the link section, we have control over our feed. We can either feed in or ramp it in. Lead in and lead out, very similar to what we saw in the profile operation. So for details on how the lead in, lead out options work, you can refer to the profile operation video in this introductory series. I'm just going to switch this to, let's say 25 thou on the lead in and the lead out. We'll do a save and calculate. And all those edges that were selected in my geometry, we can see now it has now generated the deburr operation for each of those. So a couple things to note. Back in our corner over here, it knew that the shape of the tool would collide if we went too far over, so it only deburred to a certain point along that chain. All of our bosses, we told the tool to go too deep into the part to deburr. So in this case, it didn't even bother to do those bosses. That little sliver up there wasn't even done for the same reason. It would touch the inside of that hole. And you can see that, again, over here, it is also ignoring those walls. It's pulling back before it hits those walls. So let's take a look at that in Solid Verify to see exactly what it did to the part. So as we see, it deburred enough of that edge, left a little bit over there, and it's deburring as it goes along as well. So these are edge breaking. This is deburring of the edge. It's not part of the original design. So if I did my analysis, we're actually going to see that it registers as a little bit of a gouge, depending on your settings in this window here. Now that is okay because I'm intending to deburr this, but that is something to keep note of when you take a look at your target and machine stock comparisons, that the chamfered edge, the deburred edge, was not part of the original design. So this is actually a after the fact kind of operation. Any questions on this or anything else from SolidCAM, just give us a call at 1-866-975-1115, extension 2. You can send us your parts, your questions via the ticket system at solidcamsupport.com, and stay tuned for the rest of the videos in this introductory series. Thanks for watching.